I recently had someone ask me about the difference between a geometrical set and an ordered geometrical set. So here I have a surface in the ordered geometrical set. Let me hide that. You'll notice I have one as well as in a geometrical set. So what I'm going to do is I'm going to make this my work object, and I'm going to draw in a curve. I'm just going to do an iso curve on this surface, and then I'm going to go ahead and do a sweep, linear sweep. So as I'm building, you'll notice everything gets put into my geometrical set. Now I'll go like that, go like that. We'll say 20 degrees, and let me make it a little bit taller. And then I'm going to go ahead and throw in a shape fillet. Oops. I picked out the surface and okay, let's go 20. Okay, so there is my order of operations that took place in my geometrical set. You'll notice that I can go to this curve and I can make a modification to this. Easy. You'll also notice that here's my sweep. If I hide show on the sweep, you'll notice that the sweep comes back. The original surface is still there. I can hide show that. The original base element that I used is still there. So if I wanted to, I can come in here and I'm gonna make another sweep like that. And then I'm going to go ahead and throw in another shape fillet. So pretty easy, straightforward. I've got all of that data in one geo set. And the other thing that I can do with this is the order in this geo set doesn't matter. I can put this stuff anywhere that I want to. Okay, so maybe I wanted to do something like insert another geometrical set, and I want the father to be geoset 1. I can call this one surfaces, for instance, or slabs, and then I can take my sweeps, put them in there, and then I can take and reorder this set put that somewhere else. Maybe I might have another geometrical set that goes in there, call it driver, and maybe that isoparm goes in there. So now I've organized this any way that I see fit, something that makes sense to me, something that's very logical. So this is the driver for those flanges. So I can come in here, I can double click on that, I can make those modifications, I can come into this fillet, either one of them, make those modifications. The order of the tree doesn't matter. The other thing that the geometrical set allows you to do is, again, bring back the original base element. So that is the original base element. The surface is the thing that's driving, actually let me go here, that's driving the isoparm, the sweeps, everything is based off of that surface. So this, again, doesn't matter order-wise what's going on. Now, I'm going to go ahead and hide this, and I'm going to go to this, define and work object. So if I come in here now and throw another let's say throw an isoparm on this surface, and then I come in and throw another sweep, and then I throw in a shape fillet, you'll notice that these surfaces don't get hidden. What happens is, as you can see, they actually get trimmed. This is now, if I come in here and say reorder, you'll notice that there's no reorder children. These are stuck in this order, in this set, in this regard. I can try, if I wanted to, I can do something like this and say reorder in this fashion, and what it'll do is it'll show me the standard reorder feature, or the feature reorder that you would get when you're working inside of a body. If I go inside or before or try to move it, then it's going to follow along with the actual elements in the tree as far as timestamp. If I try to move it into here and say OK, you'll notice that it moves it in here, So there is that fillet that just popped out is no longer part of this ordered geometrical set, but you'll notice I couldn't reorder it in this set. If I try to take this and then say reorder or change geometrical set or something like that, and I pick this and try to move it in there, you'll notice it doesn't allow me to move it. Once it's out of that ordered geometrical set, because it was once linked in here with a specific order and timestamp, it cannot go back in. If I try to do something like this, and you'll see I can isolate, I can deactivate. I cannot move this back in here. I may be able to copy, and if I paste, you'll see it gives me this error because of the ordering rules, because of the timestamp order. I'm just going to undo and get that back into the ordered geometrical set. So if I wanted to, maybe I needed to draw another curve, or maybe I want to draw another flange like I did in the last one. Throw another flange, go like that, and then I want to do a shape fillet. You'll notice, try to pick this, I cannot pick that because of the ordering rules that are in place. So the ordered geometrical set puts a timestamp into that specific geo set. So what this does is it makes the tree linear. So you don't have any option but to use the tree in said specific linear fashion. Now, one thing that you can do with an ordered geometrical set is you can say switch to geometrical set, and it'll remove the constraints of the timestamp, and then it'll go to a standard geometrical set. But what you cannot do is say, hey, make this a standard, or make this an ordered geometrical set. So the elements inside of this act more along the lines of what's inside of when you're doing solid modeling and part design. So the parent-children relationship here is in order within the tree. Some people like working with it in this manner. Some people don't. My preference is to use a standard geometrical set. This gives you a lot more flexibility. And it also, in this case, if I wanted to, for instance, I'm going to come in here, I'm going to define and work object, hide show, hide show. So this is my initial slab element. So I'm just going to copy, I'm going to paste. And what's nice about this, if I come in here, let's say make a modification to this new element, something like that, I can now easily say I want to replace this for this, and you'll notice the ordering in the tree, it does not matter. It doesn't matter what's going on. So there's the original one. Now everything's built off of this one. If I tried to do that here, let me copy, paste. The ordering in the tree becomes important. I have to make sure this goes into the correct timestamp. So if I replace this with that, you'll see I get my updates, but I couldn't do that if this surface were down here. So I'm going to undo this, and I'm just going to simply paste that element into the tree. You'll notice it goes to the bottom. Now if I tried to do that replace, you'll see that it can't do that because there's a parent-child relationship. The order in the tree, basically, I can't build this because this has to be built on top of that, which now this appears first in the tree, this appears next, so on and so forth. So in order to get this to work, as you saw previously, I had to have this up here. Now what I can do is I can do a reorder, and I can say reorder after this, or I could say reorder before, select OK. Oops. Let me define and work object. Now you'll notice that what I need to do is I need to repoint everything. I need to repoint this surface with this surface. As soon as I do that, everything updates. There's that original surface. And again, the ordering rules are accounted for. So that's the basics behind the differences between a geometrical set and an ordered geometrical set.